Hey people, remember this last video? This is a little table that showed you how to get these numbers from these numbers. There was always some sort of rule that connected the first number to the second number, the top one to the bottom, right? You can probably figure out that rule having seen the last video. Well, just one little complication. They can be drawn the other way around. You can turn these things sideways and they're the same. They end up looking like this, all right? So that is literally one of these on its side. It does exactly the same thing. Instead of, whoops, there you go, you can see them both. Instead of top and bottom, they're just left and right. These numbers get something done to them to turn into those numbers, and it's always the same rule that connects them, and we have to find out what that rule is. But before we get back to this, I want to show you something brand new. Hang on. This guy. I'm just going to zoom this in for you here. Hang on a second. There you go, just a little bit bigger. Now this is called a number plane, or it's also called sometimes a Cartesian plane. You're going to see that word a lot, right? Cartesian spelled like this. Plane. Right. What on earth is it? It's a grid that allows you to plot a pair of numbers on a graph. It's fairly easy. I'm just going to walk you through the parts of it. These guys here are called axes. That's an axis. That's an axis. You've probably heard this before because you've done graphs before, right? So that's an axis, all right? Now this could have been called the horizontal axis. That could have been called the vertical axis, and sometimes they are. But maths people hate big words, right? They're the opposite of science people. Science loves big words like photosynthesis and stuff. Maths hates it, which is why you always see letters in maths, right? So instead of calling it horizontal, we've decided to call this X. Instead of calling that vertical, we've decided to call it Y. Right? About as short as you could get a name. Right? So these are axes. That's the X-axis. That's the Y-axis. And the whole thing is sort of surrounding this grid of lines. I'll get to what the grid of lines does in a minute. But there's one more thing you need to know. These axes, this axis and that axis, have a number line on it, and it starts at 0. Where they meet, both of these number lines say 0 every single time, right? And that point has a name. It's called the origin, because that's where the numbers originate. It's the origin. It's the original place they all start. And let's go 0, 1, 2, 3, 4, 5, 6. It can be going up in 2s or 5s or 10s or whatever, but as long as it's consistent. You can't go 1, 2, 3, 4, 10, 11, right? You can't do that. As long as each gap is the same gap between the numbers as well. That's a gap of 1. 1 to 2, 4 to 5, they're both gaps of 1. Right? And as long as the scale there matches the scale there, that's nearly always the same. So if this is going up 5, 10, 15, 20, this one will be too. It'll go 5, 10, 15, 20, 25. All right? But that doesn't happen very much. Nearly always, it's just a regular number line starting at 0 every single time and going 1, 2, 3, 4, 5, 6. The other thing you need to know is because the reason these arrowheads are drawn on the end, that tells you that this actually goes on forever. It doesn't stop at 6. You can draw these going up to 10 or up to 100 or 1,000,000. They can be as big or as small as you want. So that's a Cartesian plane. I'm going to show you something. I'm going to get another clean one because I've just made this one pretty messy. There you go. One brand new one. So what do you do with it? Well, you do two things, and they're actually the opposite of each other. One of the things you do is you name the places on this plane. Right? For example, there's a name for that spot. Having gone through this number line creation, there's a name for that spot. A really easy name that no one's ever going to get wrong. The name of that spot, I'm just going to call it A there. I'm going to write over here, A is 4, 2. And the reason it's called 4, 2 is because if you start at the origin, always start there, and you go 4 across and 2 up, you get to A. That's the spot. The first number is always the across number. The second number is always the up number. That is the fastest way to describe that spot. Right? Instead of writing a sentence that says start at 0 and go 4 places to the right, and then turn left and go 2 places up, and then stop there, that's the point. You just go 4, 2, and everyone knows what you're talking about. Right? Now, X and Y are in alphabetical order if you go X, Y, and that's the way the numbers go as well. They're in alphabetical order. The first number in this pair, it's always written as a pair of numbers with a comma in the middle, brackets around it, that's it. Right? First number of the pair is always the X, always horizontal, and the second number is always Y. Right? So this one up here, start here. How far across do you have to go? 1. How far up do you have to go? 6. Right? So that, let's call it B. So B is 1, 6. Right? Piece of cake. I'll show you a few more. I'm going to change colour because I'm sick of red. Got to go blue. All right, so over there, that'd be 6, 6, right? 6, 6, right? So this is C, and that's 6, 6. Right? So if somebody said, where is 5, 1? You just start here and go 5 across, 1 up, that's 5, 1, so that's D. So you can do it in both directions. Right? You can either be given a point and use the numbers to name them, or you can be given the numbers and have to find the point. But it's child's play, isn't it? It's absolutely easy. Right? A couple of slightly more tricky ones. What do you call that? Have a think about it. You follow the same rules as per usual. In maths, if you're doing the same thing, you do it the same way. Right? How far, let's call that E. I'm going through the alphabet. Okay, so E is what? How far across did we go from here? 1, 2. How far up did we go? We didn't go up at all. We went up 0. So the coordinates of that, the name of that point is 2, 0. And similarly, up here, that one there, that's F. This is the last one I'm going to show you. The name of that one, let's put it over here. What two numbers? How far across do you go? You don't go across. 0. How far up? 1, 2, 3, 4. Nowhere across, 4 up. That's how you get to F. Okay? And last but not least, the origin itself, that spot there, has the coordinates 0, 0. Right? Nowhere across, nowhere up. Stay where you started. Right? This is how it's done. Now, you can use non-whole numbers for this. Just because the grid lines are only on the whole numbers, that doesn't mean you can only put a dot where the two grid lines cross. You can have a point that's, say, there, for example. Right? So this would be 1, 2, 3.5, and 5. So that'd be 3.5, 5. That one right there. So it'd be 3.5, 5. So there's no limit to sort of how many decimal places you could have it or whatever. But in most cases, you're going to get nice whole numbers. Right? So the point is there are two skills with this, and they're the opposite of each other. Number one is somebody drawing a dot and saying, name that place, right? Like 4, 2. And the other one is the opposite, giving you the coordinates, giving you 5, 1 and saying, put it on the map, right? I think it's absolutely easy. Child's play. But what does this have to do with this? Right? I'm going to show you now. Okay, this is what it has to do with each other. I'm just going to get them centered for you. Okay. Every pair here is actually a pair of numbers that you could plot on this graph, right? That is 1, 0. Remember, this is often called X and Y instead of input and output, or Fred and Wilma, or whatever I said the other day when I changed the names every time. Finger and toe, I think I said Megan and Harry. Right? It's often X, Y. And there's a convention here that when you're going to plot these points there, they again go in alphabetical order. The first one you show is X, the second one you show is Y, and the Y is dependent on X. Right? Remember, there was some rule that did this? There was some rule that connected these two things, that you had to find out what it was. You had to start with that number and do something to it to get this one. And you had to do the same thing to this number to end up getting that one. And the same thing to that number to end up getting that one. But you start here and you end up there. Right? So what this number ends up being depends on what number you started at. Right? And if you see these tables and and you're asked to turn this into a pattern on the graph, what it means is that you pretend that each of these is one of those coordinates. So this is sort of 1, 0, right? So that first entry there is actually the point 1, 0, x, y, start, finish, okay? And you're asked to plot these points. Now, if there's a pattern here, if there's one rule that has been applied to all of those numbers and you've done the same thing to those numbers to get to these numbers, you tend to get a pattern made by the points. Well, let's have a look at this. So I'm going to plot this one. So 1, 0, again, alphabetical order, x, y, 1, 0, across 1, up, nothing. This is 2, 2, across 2, up 2. There you go. Next one, 3, 4, across 3, up 4. 3, 1, 2, 3, 4. 4, 6, 4, 6. And I'm not going to fit these two on this because it stops at 6 and these guys go up to 8 and 10. I would have had to go 5 and then up 8 and then 6 and then up 10, but I can't do that because it's off the planet. All right, notice something about that? I noticed something about that. It's looking pretty straight to me. Look at this. That is a straight line. They nearly always make some sort of predictable pattern. So this one happened to make a straight line. Most of them end up making straight lines, by the way, right? Some of them make curvy patterns, but typically straight line, right? So if there's been one rule, I mean, if this is just higgledy-piggledy random figures, you won't get a pattern. But if there's one rule that's been applied to these things, it's been done to this, to get those, you'll end up getting a pattern, right? I'm going to show you a few questions that I saw in the book about this. Okay, found this in a maths textbook. They've given you the rule and they've given you an empty table and an empty graph, and this is what you have to do with it. Now, we have done this before, right? We've used these rules and filled up tables like this, and we're going to do it right now. So firstly, they've written input and output here, and it's always the output equals the input and you do something to it, okay? So we're going to start with some numbers here. I'm just going to go 0, 1, 2, 3, 4, okay? You could pick any numbers, but obviously you're going to pick numbers that are on here, right? So don't go 10, 11, 12, 13, 14, because you're going to have to plot this on this graph somewhere. So it has to fit, right? Keep in mind, this can go forever. You can do these rules with any numbers at all. You could put 1,000 in there and find out what the output comes to, right? But if you're going to put it on here, keep with little tiny numbers like this. All right, so that's the start. What should these be? So the output equals the input minus 1. 0 minus 1 is minus 1. 1 minus 1 is 0. 2 minus 1 is 1. 3 minus 1 is 2. 4 minus 1 is 3. We did this in the last video extensively. So if you can't quite remember what I'm doing, go back and check out the last video, okay? We did it 100 times. All right, so having done that, these are literally points on this graph. So there's a point on that graph called 0, minus 1. I'll show you where the minus is in a minute. Right? And then there's a 1, 0. Keep in mind, it's always first, second, second. X, Y, alphabetical order. Right? 2, 1, 3, 2, 4, 3. Okay. I'm going to do that one last. I'll do the other ones first. We'll come up to the negative in a second. All right. 1, 0. Remember, it's across up. Okay. X, Y, alphabetical order. Right? 1, 0. 1 across, 0 up. There you go. 2, 1. 2 across, 1 up. 3, 2. 3 across, 2 up. You can already see it's going to be a straight line. I bet the next one's up here. 4, 3. 4 across, 3 up. Yep. So if there was a 5, you can either do this and figure out what that comes to, or you can now just extend the graph and figure out what it would come to. If there's a 5, I reckon the other number has to be a 4. I'm going to put it there. Right? And sure enough, if you do the rule, right, x, 5, put a 5 with x is 5 minus 1 is 4. 5, 4. 5, 4, right? It all matches up. Okay. I told you I'd do this one last. Let's do it now. I'll show you where the negative numbers are. Now, they're not really available on this graph, but I'll show you where they would be. Right? So that's obviously 0 across, so you're not going to go across anywhere. Minus 1. Well, number lines do go positive and negative, right? You've seen number lines before that look like this, right? And they go 1, 2, 3, etc. And down this way they go minus 1, minus 2, minus 3. Okay? Like I said, these guys are just two number lines, and they go into the negatives as well. So you can draw this number line backwards. 6, 5, 4, 3, 2, 1, 0, minus 1. Right? Minus 1, minus 2, minus 3 would be going that way. And you can draw this one backwards as well. 6, 5, 4, 3, 2, 1, 0, minus 1, minus 2, would be going down this way. Right? So this can be not a corner, but an intersection. And you can have the grid going down here and through here and across there. Right? And you'll see that soon enough. But for the purposes of this, all we needed was to fit this. So 0 minus 1 would be down there. Right? Because that would be 2, 1, 0, minus 1. Okay? And of course, once you've got the pattern of the dots, you sort of knew it was going to be down there anyway. Because again, it'll follow a predictable pattern. This is all about finding a pattern and using a pattern to predict things you don't know, right? And now, without doing any more of this, I know exactly where that point and that point and that point and this next point are going to be, right? Because I've got the line to use to predict it. I don't have to do this anymore. I don't have to work out every single one of them. Right? The whole idea is I've found a pattern and I have a way to use that to predict what happens next. That's the whole deal. This is just another way of showing this, and I think it's quite an elegant, simple way to do it. I'm going to show you another one. Get rid of that one. Okay. Y equals 3x minus 3. All right, so let's get some numbers here. 1, 2, 3, 4, 5. All right. For each one of these, I've got to put it where the x is, because that says x. Now keep in mind there's an invisible times sign there. It's 3 times x. Right? Remember I told you, again in the last video, I told you they normally leave that out because it looks a little bit too much like another x. So it can confuse people, so they just write them up next to each other. Okay, so that's 3 times x minus 3. Okay, so if x is 1, it's 3 times 1 minus 3. 3 times 1 is 3. 3 minus 3 is 0. So when x is 1, y comes out to 0. Put a 2 there. 3 times 2 is 6. 6 minus 3 is 3. Put a 3 there. 3 times 3 is 9. 9 minus 3 is 6. And by now, just like in the line, you start to see a pattern. 0, 3, 6, it's probably going to be 9. Looks like it's going up by 3, right? 3, 6, 9, 12. Just make sure of it. 4 times 3 is 12. 12 minus 3 is 9. Yeah, there you go. Next one will be 12. All right. Whole idea is to look for a pattern, and as soon as you find it, everything becomes easy because you just continue the pattern. You don't even have to do any more maths. Okay, let's put that over here. X, Y, across, up, horizontal, vertical, says on the graph. It's pretty hard to forget this. Okay, start at the origin every single time. That's your starting point. 1, 0, 1 across, 0 up. That's one of the spots. 2 across, 3 up. 2 across, 3 up. Oh, this is going to be steep. 3 across, 6 up. 3 across, 1, 2, 3, 4, 5, 6. So that's 3, that's 6, yep. 4 across, 9 up. Well, you can't fit that on this. 4 across, 9, it's going to be way up here somewhere, right? But again, it doesn't matter because you've done enough to see that the pattern is a really steep line going up like that. And you can grab a ruler and join the dots. Done. One more. Okay. The only way they're going to make this harder is to make this look harder, right? So this has got a fraction in it, and people don't like fractions, right? So let's deal with a fraction. Never be afraid of something that looks hard. Most of it's pretty easy. You do the same thing. That is a times. It's a half times x. So let's get some numbers here that are on here. So 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Okay. A half times something. What's a half? I'm going to start at 4 because I know that a half of 4 is 2. A half times 4 is 2. Right? A half of 2 is 1. Half times 2 is 1. When you say a half of 6, what you're mathematically doing is multiplying it. It's a half times 6. It's 6 halves, which comes to 3. Right? If you had 6 half pizzas, you could put them all together and only make 3 pizzas. Right? Okay, here's where a few fractions come in. Half of 1 is a half, of course. A half of 3 is 1 1/2. And a half of 5 is 2 1/2. If you couldn't figure that out in your head, use a calculator. That's what they're for. Right? Eventually, you'll start remembering these things and you'll be able to do it in your head. But for now, it's okay to have the training wheels on for a while. Okay, so we've figured this out. It looks a little bit messy, but don't worry about it. It's just another number. Now we're going to plot these. 1 across, half up. Be careful. 1 across, that's 1 up, so a half up would be there. Right? So I'm just going to put a spot there. 2 across, 1 up. 2 across, 1 up. And again, if you've done this right, it should start to show a pattern. Right? So if it ends up going all over the place and doing U-turns and so forth, you've probably got these calculations wrong in the first place. Do this again. Right? But this should all go in a straight line. 3, 1 1/2, 3 across, up 1 1/2. There's 1, there's 2, 1 1/2 is halfway between. And yep, look at that. It's going to be a straight line. 4, 2, let's see. 4, 2, 5, 2 1/2. 5, 2 1/2. Great. By the way, what if I put 0 there? A half of nothing is nothing. And sure enough, this line is going to hit 0, 0. It's going to hit the origin. So once again, once you see the pattern, join the dots, and you're finished. There you go. You've just had your first experience with number planes. Good luck.